The second traceability and monitoring knowledge area process is about establishing the relationships and dependencies between the product requirements and the product information. It is part of the traceability and monitoring knowledge area and the executing process group. It can be defined as the process of tracing or setting linkages between and among requirements and other product information. The key benefits of this process are that it helps in checking that each requirement adds business value and meets the customer's expectations. Also, it supports monitoring and controlling the product scope. So this process will help us that each requirement is linked to at least one business objective and that it will meet the customer's expectation. It is part of the executing process group. The inputs, tools, techniques, and outputs of this process, we will have three inputs: the product scope, the requirements, and the other product information, traceability and monitoring approach. The tools and techniques will be the feature model, the requirements management tools, story mapping, story slicing, and the traceability matrix. And the key output will be the relationships and dependencies. The data flow diagram of this process showing that the inputs, starting with the traceability and monitoring approach, which is an output of the previous process, determine traceability and monitoring approach. The product scope, which is an output of the assemble business case process, part of the needs assessment knowledge area. Requirements and other product information, which is an output of the define and elaborate requirements. All these will be inputs to the established relationships and dependencies. The outputs, or the key output, which will be the relationships and dependencies, it will be used in the define and elaborate requirements process and in the prioritize requirements process. Also, it will be used in the select and approve requirements and in manage changes to requirements and other product information. As product information is progressively elaborated and additional details surface, relationships and dependencies are created and progressively elaborated. Product information is traced to help provide different and complete views of the product scope. The linkages among different components of product information will help you do the following. First of all, ensure that product information adds business value and meets customer expectations. Tracing each component of product information to the business need, goals, and objectives will help us ensure it's relevant. Each product requirement should be linked to at least one business need, goal, or objective in order to make this requirement valid and relevant. To manage scope, it will help you manage scope. Non-value added product information is highlighted through product information that cannot be traced back to the product scope and business goals and objectives. It will minimize the probability of missing requirements. Forward traceability helps ensure that product information is not dropped as product information is elaborated, built, tested, and implemented. To perform impact analysis while analyzing changes to product information, the linkages provide a comprehensive view of the related components that may also require changes. It will help you also make release decisions, implementation, benefit or value relationships, and dependencies between product information may inform certain release decisions. So creating these linkages, relationships, and dependencies will help you with these 5 bullet points. Ensure product information adds business value, manage scope, minimize the probability of missing requirements, perform impact analysis, and make release decisions. Because requirements are often related to other requirements, sometimes a requirement is not able to be satisfied in a solution without including the other requirements to which it is related. Some examples of relationships between requirements. I had one question in my PMI PBA exam about these types of relationships. Starting with the subsets, a requirement may be a subset of another requirement. This figure displays requirements 1, 2, and 3, each as a subset of requirement A. You can see here that the 3 requirements here are subsets of requirement A. For example, requirements 1, 2, and 3 could represent different nuances of a process, where A represents common elements across the subsets. Requirements 1, 2, and 3 could also represent the different components of the parent process A. This is an example of a subset relationship between different requirements. The second type is the implementation dependency. Some requirements are dependent on the implementation of other requirements before they can be implemented. For instance, if requirement A is dependent on requirement B, then A cannot be implemented until B is implemented. This is an example of the dependency or the implementation dependency. You cannot finish one requirement unless the other one is implemented. The third type is the benefit or value dependency. Sometimes the benefit of a requirement is unable to be realized unless another requirement is implemented first. For instance, requirement A can be implemented, but the benefit from doing so may not be achieved until requirement C is also implemented. So it's again a dependency, but it will not rely on the implementation. It will rely on the benefit or the value. The inputs we will need for this process, starting with the product scope, which is an output of the assemble business case process. Product information is traced to the features and functions that make up the definition of product scope. When there are components of product information that are unable to trace back to the features and functions defined in product scope, the value of including them should be questioned. Requirements and other product information, which includes all information about a solution and are the culmination of results from elicitation and analysis activities which were conducted earlier. Relationships and dependencies are established between the requirements and other product information resulting from elicitation and analysis. The third input will be the output of the previous process, traceability and monitoring approach. This approach will include details about the objects that will be traced, to what level traceability will be conducted, and where relationships will be tackled or maintained. The product team will monitor the approach as it is followed to ensure that the traceability work is adding value to the business analysis activities. The tools and techniques of this process, starting with the feature model, it can be defined as the scope model that visually represents all the features of a solution arranged in a tree or a hierarchical structure. The feature model shows relationships between features and which features are sub-features of other ones. The feature model helps teams establish and communicate relationships between different features. So the feature model was covered in the analysis section of this course as a scope model. We covered this tool in detail. The second tool will be the requirement management tools, which allow requirements and other product information to be captured and stored in a repository. These tools will often have functionality to maintain audit trails and perform version control to assist with change management of the requirements. It will facilitate review and approval processes throughout the workflow functionality. It will generate visual models and interactive prototypes. It will support team collaboration. It will integrate with Office productivity software for easy imports and export, track and report on the requirements status, and it will assist you in performing detailed traceability based on trace links established in this tool. All these are benefits and functionalities of a proper requirements management tool, so you can imagine the value it will add for you from the business analysis perspective. Requirements management tools catered to adaptive projects may include additional functionality to create and manage product and iteration backlogs and product burn down charts, as well as the requirements are documented in the template of a user story in an adaptive environment, and all these user stories are documented and prioritized in the product backlog and the iteration backlog. A requirements management tool does not help define high quality product information, but it will help assist with the process of storing, managing and maintaining product information. Selecting the right tool and tool adoption can sometimes be challenging for you as a business analyst. Requirements management tools should be evaluated on how well they meet the organization's need to increase the probability of tool adoption. Traceability support is a common feature in most requirements management tools today. So requirements management tools are very important for you as a business analyst. The third technique will be the story mapping, which we covered earlier. It's a technique used in an agile environment, and this technique is used to sequence user stories based upon their business value and the order in which their users typically perform them. so that teams can arrive at a shared understanding of what will be built. Horizontally, the story maps shows what will be delivered within an iteration, and vertically, the story map depicts higher level groupings or categories of user stories, with the ones on the top are the ones with the highest priority. User stories may be grouped by different categories such as functionality, themes, or application. Story mapping can be used to establish relationships between user stories to iterations and higher level categories. Now, another technique is the story slicing. It is also used in an agile environment. It's a technique used to split requirements or user stories from a higher level to a lower level. In some cases, you will have big user stories which you need to decompose or slice them down to smaller parts. Story slicing is a means of establishing relationships between requirements, as lower level requirements or user stories are subsets of higher level requirements or epics. So here you can see that the themes are the biggest level or the highest level. Themes can be broken down to epics. Epics are large user stories which should be sliced to user stories, and the user stories will be sliced into smaller tasks. The traceability matrix tool, it's a very important tool, and you should expect a lot of questions in the PMI PBA exam about this tool. It's a grid that links product requirements from their origin to the deliverables that satisfy them. The matrix can support linkages among many different types of objects, providing a mechanism for tracking product information through the project and product life cycles. A traceability matrix can be used to establish relationships among product information, deliverables, and project work to ensure that each relates back to business objectives. Establishing these linkages manages scope creep by ensuring that only relevant product information is incorporated into the solution. On projects that are using an adaptive life cycle, the product team may choose to develop an interaction matrix. It's a lightweight version of the traceability matrix that is used to determine whether requirements are sufficiently detailed or if any entities are missing. I had one question in my PMI PBA exam about the difference between the interaction matrix and the traceability matrix. Just keep in mind that both serves for the same purpose. However, the traceability matrix is used in a predictive environment, while a lightweight version of this matrix is known as the interaction matrix that is used in an agile environment. The main difference between these two types of traceability matrices is that an interaction matrix is a temporary artifact that represents a snapshot in time, whereas a traceability matrix is typically maintained throughout a portfolio, program, or project. This is the key difference between the traceability matrix and the interaction matrix. Now, what are the outputs of this process? We will have one key output, which will be the relationships and dependencies. They are the linkages established among objects such as components of product information, deliverables, and project work. Relationships and dependencies are established to help ensure that product information adds business value and meets customer expectations, manages scope, decreases the probability of missing requirements, performs impact analysis, and makes release decisions. So the relationships and dependencies will make sure that each of the product requirements you have captured is linked to at least one of the business goals and objectives. It will help you also meet the customer's expectations, manage the scope creep, decrease the probability of having any missed requirements. Tailoring considerations, it is known as the backlog refinement process in an adaptive environment. It typically establishes linkages between user stories and the acceptance criteria. The acceptance criteria is how you are going to make sure that the work has been completed for a specific user story. So for each user story, you need to have an acceptance criteria, and this process will help you establish the link between both the stories and the acceptance criteria. It might trace to objectives. Epics or user stories may be traced to features and acceptance tests. Any components of product information might trace forward to design and test, and ultimately to the solution, and backward to the goals and objectives, performed iteratively via story slicing or story mapping as new items are added to the product backlog. Maybe forms of direct tracing such as attaching a visual model to a story or linking user stories and acceptance criteria. The deliverable of this process will be the feature model, a story map, interaction matrix, or linked product information like stories and acceptance criteria that may be stored in a requirements management tool. In a predictive environment, this process is known as the established relationships and dependencies, or trace requirements. The approach will be minimal to extensive tracing, bidirectional between all components of product information and deliverables that may contain product information. Established throughout the product lifecycle. As more product information is defined, more detailed traceability is performed after an analysis phase of a project to trace forward to design and test and ultimately the final solution. Small to large traceability matrices are the deliverables of this process. Regulatory environments often dictate formal traceability. Traceability information may be stored in a requirements management tool. Collaboration in this process, joint review of the relationships and dependencies with project team members is needed, as these relationships may impact release decisions. On predictive projects, tracing may be performed between business analysis deliverables and deliverables produced by other project team members, such as project requirements and design, development, and test components. Business analysis work to define product information may be performed by different people. Therefore, collaboration is required to understand relationships between the different components of product information. So the key collaboration will be between the business analysis team and the developers and the design team.